Wearing the coolest shirt in the world. Space shirt, space shirt. So today we're talking about gravitational fields. And before we kind of get into that, let's actually talk about what a field really is. Because we might have heard like on a movie or something like force fields up or something like that. Or like activate my force field, you can't hurt me now. And just what is a field? So from a physics standpoint, a field is really something that just somewhere in space, there's a designated quantity or number that is associated with each point in space. And technically, if you wanted to say, you could call it space-time. But it's just some value associated with each and every single point. So if we take gravity or a gravitational field and we look at that as an example, we could have Earth here, and we'll draw a circle with kind of a plus mark through it, or a check. That's the Earth. And the Earth has some gravity. Because of that, every single point in space, every single point, like this entire screen would be black if I hit every single point. But every single point in space has a different amount of gravity associated with it due to the fact that the Earth is, influencing that point in space. Now, if you had more than one object, like here's Earth and out here's Mars, technically we'd have to look at both Earth and Mars's gravitational attractions, add them together and say, hey, look, at this point right here, there's some combination of the fields. There's a field interaction there. But it's simply just a value at every single point in space for everything. Our gravitational fields, because gravity is an attractive force, our gravitational fields are going to point towards objects. So, maybe if you get close to Mars out here, Mars will take you in here. But there could be a point, some special point between Earth and Mars where their gravitational fields, are pulling against each other in the same amount, and we just kind of get nothing there. That could happen. So these gravitational fields exist, and they're just numbers for every single point in space. There are more than just gravitational fields out there. There are many different types of fields. Electromagnetism has fields in it. Traditionally, if you're talking about electrostatics, we can talk about an electric field. That's just how these points in space would influence a positive or a negative charge. For magnetism, you have magnetic fields, which not only would influence magnetic objects, but they could also influence moving charged particles. So there's a lot of different fields out there. You can get into a whole mathematical world of field theory and kind of what fields represent and like tensory stuff. We're not going to do that here. This is an intro level course. But these ideas of fields, they are just values for each point in space. So that's kind of what a field is. Traditionally, whenever we kind of write out our fields, we typically write that the field, whatever it is equal to, and for our case, this isn't always true, but for what we're going to look at, they're normally equal to some force amount, that's why it's a force field, divided by some quantity. For us, this quantity is going to be mass, but it could be something like a charge if you were looking at an electric field. And the reason why this will occur, and we'll see this shortly, is for our gravitational fields, which is just gravity, little g, we can call that equal to a force, and our quantity is mass. So it's like a force per some amount of mass you have in existence. This actually relates right back to the idea of this force. We would traditionally call that the weight, and we would say that weight just equals moving the m over mg. So we already knew this equation. We're just writing it in a slightly different way to get the field out of it. So this is our gravitational field. The other thing that's nice about having a gravitational field is with gravitational fields or with fields in general, if you are at a specific position in the field, you can get a potential. And if you put something into that position, now you can have a potential energy. Remember, there is a difference between a potential, which is just a field and the location, versus the potential energy, which is an object at a location in the field. we'll kind of get more into that as we go along, and what we've seen a little bit with gravitational potentials and potential energies. So this is just a quick little idea of a field. They're just quantities in positions of space. It's nothing too crazy. Sci-fi cultures kind of took force field from us, but this is what we're really talking about in a physics sense. It's just, here's points in space, here's how much stuff for whatever quantity we're talking about exists, and that's a field. So with that, this little conversation is finished. Take it easy. Wearing my favorite shirt.